to the agenda, a couple things. We're just going to ask everybody to stay on mute. No cameras, just to avoid any potential bandwidth reasons, because we are recording this and posting it. We're going to try to keep it as clean as possible. And we will be dumping in to the chat here, if not already done, a link to a form for any Q&A. So if you do have a question as we work through the different topics in the presentation, if you want to submit that question, that does come directly to us and populate, and we'll jump into the Q&A at the end of all the slides and take whatever time is necessary to work through those questions. So we'll touch quickly on the agenda. So I'll do a quick team introduction so that we can introduce our relatively new team here at National Grid around RNG interconnections. I'll take a few minutes to do a safety message around natural gas, and we'll dive into the basics of RNG. We'll touch on the new interconnection application process that we've developed here over the last few months through the National Grid website. Touch on gas quality, carbon considerations, and then remote feedstock solutions. So you'll get to hear from myself and a couple of the other team members as we move through that. So just as an introduction to who we are as part of this RNG interconnection team. So we do work in a department called Customer Energy Integration here at National Grid. We live in the customer organization, and that's our main focus, is dealing with the intake process and dealing with the developers and the customers looking to interconnect RNG. We're going to be involved throughout the process, from the beginning application through to the interconnection of that, looking to be an advocate, right, a support person to make sure that that those contacts exist and you always know who to call when you have questions, or as different things pop up. So our team is meant to be that point of contact into National Grid as we move through that RNG interconnection process. So I'll introduce myself real quick. I'm Will Kern. I'm the manager for our RNG interconnection group. Been with National Grid for over 20 years, the majority of it on the electric side, but moving over into the RNG interconnection space. Right now we have a couple of integration consultants on the team. One is John Carlin, the other one is Ariel Golshin. So they've moved into this team. We've been working together for about 9 or 10 months now to get things stood up and integrate ourselves into the overall process, understand that process, and work through developing that intake or application process overall. You can see down there at the bottom, we've set up a email box that you can get directly to anyone on the team, right? rng.interconnections@nationalgrid.com. Feel free to use that. There's also an option in the from the website, from the RNG interconnection page on our website, with a contact us button where you can get to us with questions too. Same sort of process. So over the next several slides, you'll get to know John and Ariel a little bit as they present. But we are here to help, and we're here to learn also too. So definitely interested in touching base, answering questions, and anything that would ultimately pop up, right? Feel free to reach out to any one of us directly, or through that generic RNG interconnections mailbox there at the bottom. So let me dive quickly into a safety message. As is customary here at National Grid, we like to kick our meetings off with safety messages. So what I want to touch on is signs of a natural gas leak, right? So, this isn't just, when we go to work every day, these things pop up. This is everyday life for us at our homes, at our other places of work that may not be directly related to natural gas. But if you hear hissing sounds or see air bubbles outside your home, right, those are warning signs, right? If there's dead or dying plants in the general area of that gas leak, That's something else that should identify the potential risk of a natural gas leak, and something that should be looked at. Getting into a little bit more intense, right, is physical symptoms of natural gas poisoning, right? Feeling sick and um, uh, after too much exposure, right? Or then even just in your bill, seeing a higher than normal gas usage, right? If you're used to, being pretty consistent across the board month on month, if that jumps up considerably, right, there may be a leak issue. And then, I think what has been known, whether you're industry or not in the industry, there's an odorization of the natural gas. Natural gas by itself doesn't have a smell. So it is odorized with a rotten egg type of a smell. So if you do smell rotten eggs, right, that is most likely related to gas, and is something that you should be looking into a little bit deeper. And then how does that really start to apply to what we're doing here with RNG? So just a quick one-line diagram of what the RNG interconnection looks like, and then touching a little bit more on the odorization, right? Where that comes in, what step that comes in the overall process of the development of RNG and the injection of RNG into what would be the national grid gas system here. So I won't dive too much into that, but as we move into the next slide, just a couple of RNG odorization notes, right? It's good to use unscented soap to identify if there's air bubbles or leaks, if they're present on the equipment there, just to make sure. Consider portable gas detection units, right? As you guys get into building these sites, or having these sites built on your on your property there, it's good to always just make sure that those leaks don't exist. The odorization requirements do vary state to state. So depending on if, as National Grid is working in New York and Massachusetts, right, it's good to understand what those requirements are for the state that you're located in. So definitely look into that. And then when working on the assets downstream of the odorant injection, just because you smell the smell doesn't mean that there's a leak, right? It could just be present there based on your proximity to where that odorization step is taking place. So just kind of keep that in mind. Always good to look into it and to make sure, but realizing that the smell, when close to the odorization, may linger, in and around that general area. So just a number of notes, safety related notes here for as we get into these RNG interconnections going forward. So with that, I will shift gears into the basics of RNG, and I will introduce Ariel to take over the next few slides.
Thank you, Will. Is my audio coming through okay?
Yes, we can hear you.
Perfect. All right. Good morning. My name is Ariel Golshan, and I'm one of the consultants on Will's team. Been with National Grid for about 5 years now, entirely in the gas space. So now we're going to get into the basics of RNG. What is RNG? RNG is defined as pipeline compatible gaseous fuel derived from biogenic or other renewable sources that has lower life cycle carbon dioxide equivalent emissions than geological natural gas. For our purposes, I would say that RNG will be slowly replacing fossil natural gas as we transition to a clean future. Next slide, please. So on this slide, we have the results of a study performed by the American Gas Foundation. So under conservative circumstances, RNG could over 37% of National Grid's residential use. With more ideal circumstances, it can account for up to 95%. And I would just say to keep in mind that this does not include other technologies such as electrification or hydrogen blending. In either case, the greenhouse gas emissions would decrease significantly. Next slide, please. And here we have some data from the US Department of Energy. Although it is a little outdated, we can see that there is a positive trend in RNG projects with respect to time. The National Grid would like to be at the forefront of incorporating RNG into our system as we seek to achieve net zero by the year 2050. Next slide, please. Okay, and now we're going to touch a little bit on the interconnection application process along with our web page. So if you can please flip over to the next slide. Here we have the URL up for our RNG interconnection web page. The easiest way to find it, I would say, is just to search for National Grid RNG in Google, and it'll pop right up. And here's the banner of the site in case you just want to know if you're on the right page. You see that RNG interconnections along with the background of our Newtown Creek facility. Okay, and here's just a brief site overview, just a couple of the key sections from the web page. I labeled them A, B, and C. It's not in order, but just to kind of break it up. At the top here, we have our getting started section, with a couple steps, and most importantly, that submit pre-application button, which will take you over to our Microsoft form that will kick off the application process. On the bottom left-hand corner, we have just a what is RNG section, a little bit about RNG along with our gas quality requirements. So it's definitely, key to read up on what's required for the RNG that will be injected into our system. And last but not least, on the right-hand side, we have the Get in Touch section. You can, submit any questions, comments, or even join our mailing list if you're interested in finding out more. So here's just a brief snippet of our pre-application. It's done again through Microsoft Forms. And, it'll collect some preliminary information from you, name, address of your site, phone number, email address, etc. And just the point is to remember to review the gas quality standards table that was shown earlier. That is, one of the questions on there to make sure that the gas will conform to the requirements. And I will briefly hand it over to Dan Settle to talk a little bit about gas quality.
Dan, I think you're muted.
What about now? Can you hear me now?
Now you're good.
Yes.
Okay. All right. So quick overview, what is gas quality? So gas quality is looking at the gas and what makes it up. We say natural gas as if it's one thing, but it's actually a mixture of several other gases, mostly methane and ethane, several other hydrocarbons, some contaminants like hydrogen sulfide, and inerts like oxygen and CO2. So it's actually a mixture of several gases, and because of that, we want to be able to look at what makes up the gas and make sure that it's going to be usable by our customers at the end of the system, and also safe to for our pipes and other equipment, and doesn't cause issues like corrosion. Because we've used gas for so long, we've have several key components here listed of what natural gas should look like, things like what its heating value and moisture content should be. And those are meant as guides to, these are kind of high-level guides to start us to say, what should natural gas look like? And by giving those guidelines, it helps us, make sure when we add new sources of gas, such as RNG, that they're going to be able to come onto our system and function properly, and make sure our system is still safe and will operate properly. So I think next is John.
Got one more slide here. Thanks, Dan. Just last but not least, our get in touch slide. Mentioned it earlier, but if you have any questions at any time during the pre-application process, you can, either email us at that rng.interconnections email address, or you can just submit this form and we'll get back to you as soon as possible. So with that, I will hand it over to John to talk a little bit more about carbon considerations.
Great. Thank you, Ariel. Thank you, Brian, Dan, for running us through the gas quality stuff. Where I'm going to concentrate on here is the carbon considerations of an RNG project. How do we look at carbon and the impacts of it, and how does it affect the greenhouse gas emissions of our territory? So National Grid considers the full carbon life cycle for that carbon intensity. So when we do a carbon intensity study, we're not looking at what are the emissions right now, we're looking at what are the impacts across 20 years or 100 years. And methane is 25 times as potent as CO2. Now, I'm going to get into that a little bit more on the next slide, but it's much more than that at the beginning, but it's got a shorter life cycle. So it's got that shorter lifetime, but it traps so much more heat when it's released that we need to capture that and use it. And so RNG is a really good way to capture that, put it into our pipelines, and avoid releasing that out into the atmosphere, as it happens a lot currently. And that release affects some of the numbers that you'll see on some of my next slides. So the next slide is global warming potential, and I'm going to start here with the EPA definition. I'm going to read this word for word because it's kind of worth considering. The global warming potential was developed to allow comparisons of the global warming impacts of different gases. Specifically, it is a measure of how much energy the emissions of 1 ton of a gas will absorb over a given period of time relative to the emissions of 1 ton of carbon dioxide. So you'll see here, and when I say you see GWP 20, GWP 100, that's 20 years or 100 years. So in 20 years, the effect of methane is 80 times, a little over 80 times more than CO2. That goes down over the life cycle because CO2 lasts longer, but capturing that methane and using it drastically decreases the cost of having cows, having sheep, having chickens, digesting in a landfill. These are all places that release methane, and you can flare it to turn it to CO2, in which case you're just straight reducing that GWP, or you can displace natural gas and put it in the pipeline. So the big points here are initial effect of methane, really, really big, and even the long-term effect, because of that huge initial impact, is still really high. So RNG projects reduce methane emissions, they beneficially use methane, and then they combust it and convert it to CO2. So the effects stack up. My next slide gets into the numbers on that a little bit. You're going to see all of the ones that I highlighted in red are the major impacts, the major negative impacts, and then the green are the positives. I've got them. You can look at that as positive or negative, but the beneficial is in green and the environmentally hurtful is in red. So you can see those first 4 columns, they've got, there is a emissions release associated with each of these feedstocks. However, with dairy and food waste, while there is that release, there's also a huge negative or reduction in emissions from taking the methane that would have been released and combusting it. And that's just for combusting it. That's not counting the removal of the natural gas that's being emitted, that's being avoided. Now, the other two in the first four, landfill and wastewater facilities, those are net increases in emissions by converting that to RNG. However, it doesn't, what you don't call out specifically here is the difference. So while they are net increases, they are a significant decrease once that gas goes into the pipeline, because every CFM from those sources is a reduction in that last. So even though you're releasing 19.6 kilograms CO2e per MMBTU, you're reducing the end use emissions associated with the natural gas by 60 point something. So that's the point here of this slide, is really your emissions reductions. On those first two, just putting them into a digester and combusting them reduces your greenhouse gas effect. The second two, putting them into the pipeline, is a significant reduction from getting that natural gas from, you know, the shale fields of the Midwest and Pennsylvania instead. Now, my next slide, is a bit of a reiteration, but it changes the context of putting those numbers that Ariel stated, those high and low potential pathways, into the context of greenhouse gas reduction. And what I'm hoping this will drive is our stakeholders to look at this and see the dark blue rectangle with that 13,000 in it represents the technical resource potential. That's everything that could possibly be turned into RNG, getting turned into RNG, would reduce natural gas by 95%. Now, our high and low resource potentials could reduce residential by 95%. The high does, the low does 37%. But the point I want to drive home is the gap between the two. That represents huge potential, and we want to engage with you on how to capture more of that. So if you have ideas that we can do on our side to make it easier for you, please reach out. So that's sort of a high level look at what's represented in the American Gas Foundation's report on renewable resources for natural gas and the effects that they can have in our territory. Next, I'm going to go on to our remote feedstock solutions. And as anybody who's been to upstate New York probably knows, that you've got a lot of dairy spread out. And this is not unique to dairy. You can find similar feedstock solutions in agriculture, or issues in agriculture and in wastewater, where you've got many of these small feedstock sources that can't really justify getting a digester themselves, or they're too far from a pipeline. And there's a lot of issues preventing those sites from engaging with RNG or RNG projects. National Grid is exploring a lot of potential solutions. So one of those is developing an RNG offloading station in upstate New York. So a trucking station where you can digest at your site and you can ship the RNG to a site where that's right next to a pipeline, and interconnection is much cheaper. There are also hub and spoke projects that are being developed where many feedstock sources ship their feedstock to a central digester and then digest there. That happens to be directly next to one of our transmission pipelines that can take all of that RNG and get it out to the rest of the network. So those are solutions that we're exploring, but we want you to engage with us on what you need solutions to, and what solutions you have to propose that we could work with you to develop. That's all I have on remote feedstock solutions, and the next slide is just the references if you want to find that AGF report, the EPA charts on how many projects there are, their definition of GWP, and all RIN transactions. That's an open source published by the EPA that you can look at. It's kind of interesting, but it's a lot of data. And with that, that's our presentation. We want to open it up to questions.
Thank you, John.
Which
Thanks,
we've not
Ariel and
received.
Dan. Yeah, so we don't have no questions have come in. So what we'll do, we don't have a large number of people on this call. So, I will open it up to anyone who may want to come off mute, who may want to ask a question. We can give it a couple of minutes here, but there were no submitted questions here throughout the balance of the presentation. So I'll open it up for anyone who wants to come off mute and ask any questions they may have.
Are you sending out the slide deck after?
Yep, great question. We will be posting both the slide deck and the recording. So all invitees to this seminar will be getting a follow-up that will have the link to where those will be posted.
All right, thanks.
What do you anticipate the timeline might be for a project review?
So, Brian, maybe I'll put you on the spot here real quick for that question, just because you've had more experience in the limited number of projects that have gone through the pipeline now.
Yeah, sure. So historically, what happens is, they'll reach out to us and we'll start establishing like the base level of information we need, right? Where is the facility located, and how much gas do we think they'll produce and as well as consume? And then we start doing what we call an initial sniff test. Historically, we can get that turned around within 2 weeks, and quite often even sooner than that. And that basically allows us to say, does this project make financial sense without getting too far into the weeds? And by that I mean, do they need to run like 29 miles of pipe to get to a transmission, as opposed to the distribution that's right next to it? But the distribution wouldn't have the takeoff necessary in the summer. So historically, we can have some semblance of if the project's feasible within 2 weeks, and then once that, we'll call it initial stip test, comes back with a green light, then it's a little bit at the discretion of the developer in terms of how quickly we proceed. We do have some templates in terms of pre-negotiated documents. However, we would need to get a gas sales agreement together, an FCRA, which is a reimbursement agreement for the interconnect. So those things take time, but it's really at the discretion of the developer.
Thank you, Brian. So I'll take this opportunity as people maybe are thinking of questions. So what we do is we do keep that link to that form open even after the meeting here today. So if you do think of a question later on today and want to submit it, right, it will pop up and will make its way back to us. So the plan would be, if we do get any of those questions, we would be putting together a Q&A doc that we would be posting in the same location as the slide deck. But yeah, if the question's not popping up right now, then by all means, you can feel free to submit later on.
Well, I have two questions. One is, once I submit my application, do I need to submit any additional documents with the application? And the second question is after application is submitted, what should I expect next? I might be getting like a phone call, a meeting, or like what that acknowledgement will look like.
Oh, good clarification. Ariel, why don't you take the second half of that question first?
Absolutely. So once you submit that application, you will get an email, an auto-generated email back from us containing just a PDF table of all your responses. And we internally receive your submission, we review it, and then we will get back to you and let you know if it's passed just our initial screening. And then you'll get an invitation via email to schedule just a meeting with us to go over the information you provided, along with any questions about the process that you may have.
And at what point will we be asking for additional documentation?
So after that, I would say, we would then go through the sniff test, as Brian mentioned, make sure that, from a planning and I guess logistics purposes, that it's feasible. And then at that point, I think we would start, executing, the documents, the agreements, and asking for, more, detailed drawings, designs, documents, etc., to really start vetting out the project.
Thank you. Did that answer your question, Vishal?
Yes.
Very good. Okay, so there still have been no additional questions submitted through the chat, so we'll give it one more shot for anyone else who may have additional questions. Please feel free to come off mute and speak up. Okay, great. So again, we'll just reiterate. Feel free to reach out. Right, we have the rng.interconnections@nationalgrid.com mailbox. We have the website that was also posted in the chat, the link to that website. Feel free to go and look around. We have some developing knowledge pages, right? As we get more information, we'll be posting that. That's where these the slide deck and the recording will be posted also, along with the gas quality chart, in addition to the ability to reach out to us directly through the website. Lots of ways to touch base with us without having to submit an application for a project. So if you're just looking to ask questions or learn a little bit more about what's going on before diving in with both feet with a project, that's what we're here for also. So please feel free to reach out. We appreciate everybody's time today, and we look forward to working with you in the future and getting some RNG interconnected. Thank you.
Thanks, everyone.
Thank you.